Alright, so today I'm going to be doing the standard of interference. As you can see, I have a 2 there, so I would like to bring that to a 4 if all possible. So the question that I'm going to do today is from chapter 35, number 5, and that question reads, two speakers emitting identical sound waves of wavelength 2 meters in phase with each other, an observer, are located as shown in figure 35.21. Now for A, I'm asked, at the observer's location, what is the path difference for waves from two speakers? Okay, well, let's see here. Let's just start on drawing this out. So we have two speakers. We're just gonna denote those by these two dots because I'm not too good at drawing that on paint here, but we're gonna give it a try. So, and they are 6 meters apart. Okay, there we go. 6. Yep. Okay, there we go. And then the person is standing 8 meters away. Okay, so just draw the person here. There we go. Ooh. All right. So he is 8 meters away. Okay. So to find the path difference between the two speakers, well, first of all, let's just let's go to triangle going here. We actually already know two of the sides. They were very nice to us in this problem and gave us what two of the sides were of this triangle. Oop, oh, curvy there. So as you can see here, the bottom is going between the two speakers is 6, and then right here is going to be 8. So we know that path 1, P1, is going to be equal to 8 meters. That's just going to be from the first speaker right here, and then up to the person right up here. That's 8 meters as they showed us. So that's going to be 8. And then path 2, we can calculate using just simple geometry. We know that for a right triangle, shown here, a squared plus b squared equals c squared. And so what we can do is take the square root of 6 squared plus 8 squared, right? Okay. And after calculating that, second here, that's going to be square root of 100 is going to be 10. So we know that the path 2 is going to be 10 meters. right? So P2 equals 10. So, and the first question, part A, was asking for what is the path difference? So we can just take P2 minus P1, and that's going to, which is going to be 8 minus 10, as you can see here, 8, or 10 minus 8. And that's going to give us change in path of 2 meters. It's bigger here. 2 meters, right? Okay. So, and we know from earlier that the speakers have a wavelength of 2 meters when they're in phase with each other. And part B says, will the sound waves interfere constructively or deconstructively at the observer's location, or something in between constructive and deconstructive? Well, we know that the second wave coming from the speaker right here, that will be 2 meters behind first, right? So they will be in phase, and that will cause constructive interference. Okay, so that was part B. And now for part C, we're doing screencast, Matt. Matt. Oh, okay. Anyway, okay. So for part C, we're supposed to now suppose the observer now increases her distance from speakers to 17 meters, staying directly in front of the same speaker as initially. Answer the questions of part A and B for the new situation. Okay, so now all we're really doing is that we're going to change this 8 to 17, I believe it said. 17? Is that what it was? Yes, 17. Okay, so we're going to be changing that and this here to a 17. Okay, so 17, right? 17. Ooh, I've got a pencil now. Nice. Okay, so just like last time, we already know the first path. So P1 equals 17 meters, right? And then from that, we can do the same thing with the triangle for P2. So that's going to equal the square root of 6 squared plus 17 squared. And that is going to be 6 squared plus 17 squared. It's 325. The square root of that is going to be 18. Oop, that was really bad. 8. Okay, so now we can take P2 minus P1, which will give us a delta P of 1 meter. And from this, we know that the speaker from the second speaker here, right here again, is going to be 1 meter behind, which will actually put it completely out of phase with the other wavelength. And because of that, that will cause deconstructive interference. And that pretty much sums up this standard.